In the last video, we learned a little bit about pixels and how to animate them and shape animation like square. Then we had a line animation, vertical animation, horizontal animation, and all kinds of animations that we did in the last video. In this video, we're going to be using some of that knowledge from the last video as well as some of new things. And we'll be building a character controller where we're able to control our square for now. In the later videos, when we'll learn about bitmaps, then we'll display our characters and then we can animate them. But for now, we'll be using squares and we'll be animating them. So by the help of some interrupts in assembly, we'll be able to catch what our keyboard is pressing and then hence moving our square a bit to the right, a bit to the left. So it's gonna be fun. So we'll start this by org100h as always, which is the standard for the entry point for DOS.com programs. And I'm gonna write a start function, right? Inside the start function, I'm gonna move AX0013h, which sets the AX to video mode, 13h, which is the 320x 200 pixel mode that we discussed. Then I'm gonna use the interrupt in 10h. The next thing I'm gonna do is values of my x and y axis. So my cx is going to be 160, my dx is going to be 100. So that is the center of my screen, and I think that's pretty much it for start. So the next thing I'm going to write is the game loop. I'm just going to call it game loop, and inside the game loop I'm gonna say move AL14. That sets our player color to yellow. The color 14 represents yellow, and I'm gonna call draw player, and this draw player is actually just gonna be a subroutine that's gonna be over here, and I'll just leave it as for now because I want to finish my game loop for now. So the next thing I'm gonna do is check for keyboard input. So if I do move AX01h and then I look for interrupt of 16h, so 01h is the bias function to check if a key is waiting in the buffer, and the interrupt 16h is the keyboard interrupt. So this just checks if any keyboard key is pressed, and if it is pressed, it basically tells us that hey, it is pressed. And until it is pressed, I'm just gonna say jz game loop. So it just keeps on repeating, and the game keeps on functioning unless a key is pressed. So the next thing I'm gonna do is to check for which key is pressed. If any kind of key is pressed, then we want to check if what's the key that is pressed. So I'm gonna say move as 00h this time instead of 01h. So 00h is the bias function that gets the actual keystroke from the buffer. And then I'm gonna say in 16h, that's the keyboard interrupt that consumes or like gets the key. The next thing I'm gonna do is push AX. So I'm saving all my general purpose registers in the stack. And why I'm doing that? That's because I'm gonna be moving AL0. So I'm setting the color of my pixel to be black. Why I'm doing that? Because when we're moving forward, right or left, I want to erase the previous box. So if we don't do that, then it will be kind of like we're painting in the VGA mode. But if we just if we want to use it as a character, we would like to remove it instead of just painting it. So that's why we are doing it. So move L0, and then I'm gonna call draw player here again, which will again draw that black pixels, and it won't be visible to us. Then I'm gonna pop AX. So it retrieves our pressed key back into the X register. So the key that we got from here is not lost anywhere, and we actually got it back because of the stack. So the next thing I'm gonna write is a bunch of repetitive things, and what do I mean by that? So I'm gonna be comparing my AH value, the key that is pressed, to a couple of hexadecimal codes that represent the up, down, left, and right arrow key. So if we say 48h, that means that hey, did the user press the up arrow key? And if they did, then just move up, which will be a label that we'll be jumping to. And let's say they didn't, and they pressed let's say, what was that, down arrow key, which is 50h, and then we want to say move down, and let's say then we have the left arrow key, which is 4bh, and they did that, then I just want to move to left. If they pressed right arrow key, right? So then I just want to move right, and let's say they want to exit the game, then we will have to press JE, compare A at 0, 1, and 0, 1 represents escape, so by pressing escape they can, well, escape the game. And then I'm going to jump exit game, which will be a label created later onwards. And then I'm going to do this one last thing, which is jump game loop. And what does this do? So let's say they press a key that is not really used in our game, then we just want them to loop back to our program if they press an unmapped key. So the next thing to do is very obvious, which is to create these subroutines. So let's say move up, and if they move up, what we want to do, so we know that dx represents the y-axis, and if we just decrement dx and then jump to game loop, that will basically make us decrement the dx, and we will move one step up. And let's say if we want to move down, then just to increment dx and jump game loop. So it's the basically the opposite of what we did before. Now if we want to, let's say, move left, then we'll just decrement cx, which is our x-axis, and we want to move to the left, so we have to decrement it, and then I'll just say jump game loop, and I'll just do these. Okay, so let's say next thing we're gonna do, move up, down, left, and now right. So let's say we're gonna move to right. I'll just do increment cx and jump game loop. So our game loop is pretty much complete. One last thing I'm gonna do is to use this exit game function, which is gonna have move ax00 03h, and then int 10h. So 0003h sets the video mode back to text mode, and then we just call the interrupt for that, and then I'm gonna say move ax4 c00h, which is DOS terminate function, and then in 20 minutes that exits from DOS. So now we really come to what Hikaru likes to call in chess the sauce of this program, and this is the draw player function, and this is gonna basically do everything to draw the character for us. So what's the first thing I'm gonna do here? Like all the time, I'm gonna just push A to push all my general purpose registers, and then I'm gonna move SI 5. So now why I'm moving 5 to SI is because that's the size of my square, 5 in width, 5 in height. So this one is basically the height counter. And remember in the last video when we created that library.asm, in that we had the we wrote this entire function, and in this one I'm just going to replicate that again. So move SI5, then I'm going to have an internal row loop, so I'm just going to say row loop, and inside this I'm going to say move di5 and then push cx. So move di5 is the square width counter, right? And then push cx is I'm saving the starting x for my current row, and after that I'm gonna move to .call underscore loop, which is gonna be the main it's gonna do a lot of operations. So first thing I'm gonna call is the put pixel. Again, like the last time, I'm just gonna call the put pixel function, increment cx, which moves x to right, and I'm gonna tell you why I'm doing that. And then decrement di, which decrements my width, j and z, I guess jump, yeah, I guess jump, if not 0, call loop. So I'm gonna jump to call loop if the di is not 0, and then I'm gonna pop cx and I'm gonna increment dx. So popping cx means I restore my x, and then I increment dx, which moves y down, and then I'm gonna, let's say, dx, yeah, so decrement si, which decreases the height, and then I'm gonna jump if si is not 0 to row loop, and then I'm just gonna pop a. So I think that's it, and then I'm just gonna return. So what this function is doing is basically generating that that square for us. So when we are here, we call a put pixel function, then we increment the cx, and then we decrement the di. So why are we doing that? Incrementing cx means that we move x to the right. So when we're on the first row of our square, incrementing cx means we move one to the right, right? And this will continue, jump if not 0 to call loop, but this will continue till my entire line is finished, which is 5, because my width is 5. So when di is 0, it will go from 5, 4, 3, 2, 1, and then 0, and then we'll go here, right? And then we'll just pop cx and increment dx, which again moves the y down. So now I go to the second row, and then I decrement si, that one of my height variable has decreased now, and then I'm gonna jump if not 0 to row loop again. So back here, and it will keep on happening again and again until we have reached the entire square. The next thing I'm gonna write is the put pixel function, and it's gonna be a bit complex, I guess, because this will have to be based on how we're moving right and left. So it will be dynamically calculating that. So first thing again, I'm gonna just push all my general purpose register. Now I'm gonna save the value of my color. So I'm gonna store it in BL, and why I'm gonna do that, because all my general purpose register, including AX, which of course has AL, are gonna be increased, are gonna be changed. The values are gonna be changed. So I'm just gonna do move AX 0 A 0 0 0 H, pointing AX towards the VGA segment, and then move ES AX. Now the ES is basically pointing towards VGA memory. Now this is the exciting part where we calculate the offset, and we're going to use something new here again, because it's also about learning. If we keep on using old things, then we don't learn anything, and this is a very important thing that's used in a lot of times in assembly. So first thing I'm going to do is move AX DX, that sets my AX to Y, whatever was my Y position, and then I'm gonna do the same with DI. I'm gonna move DX, so both has Y position now, and then I'm gonna use this new operator that I call shift left, and I'm gonna perform AX8. Now what does this do? So shift left basically moves my bits in my AX, so it will move the bits 8 bits to the left. So in simple terms, it is just multiplying it with here with 256. So it's multiplying it with 2 raised to power 8, which is 256. So y, as I said, it's basically the y position of the x. Y is basically being multiplied by 256, and then I'm gonna SHL di, which is gonna be 6. And what is 2 raised to power 6? That's 64. That means di is being multiplied by 64. And then I'm gonna add di AX and add di CX. So I think this really makes things easier. So what I'm doing here is basically calculating that offset that we did in the last video as well, but not using shift left. And how it's being calculated is that I just add, so the original formula is y into 320 plus x. So y into 320 takes us to the center of the screen, and then plus x, which moves us to the center of center horizontally, right? And that's what we're doing here. And we add DIAX, that's basically multiplying y with 320. And then I'm adding DICX, which is basically adding x in it. So I hope that makes sense, and if you want to go through the easier version of it, you can go through my last video where we have done it not using SHL. The next thing I'm gonna do here is to let's see what I'm supposed to do. I guess I'll have to yeah, I think I have to get my color back. So I'll just get my color back using AL, BL, so I'll get my color back. Then I'm going to use the offset to draw. So ESDI, again the VGA segment offset, and then pop A, come on, NeoVim, and then return. So that returns the code, and this is basically the entire code that we need for the character. And okay, let's try running it now. So now I'm inside my DOS box, and it's outputted, and now I'm just gonna run my character, and here it is. So if I press left, I go to the left. If I press right, I go to the right. I press top, I press the top. I go bottom, I go to the bottom. I mean, I press bottom, I go to bottom, and yeah, that's pretty much it. And if you notice, if you just remove that part where we were not, where we were creating the black, so we were leaving black behind, you know, on our previous render, you will see the previous render as well, and it'll become kind of cool tool that you can have for painting using your keyboard. But you can try doing that. But I guess that's pretty much it. So in the next video, we'll learn about I guess gravity and adding a surface under our character. So like when we press space, our character jumps, and it jumps with and it jumps and comes back because we'll be adding gravity, and then we'll have the surface and we'll add a collider to it, just like in modern game engines we have colliders, but in this we'll kind of have to build that, and it's very interesting actually how we're gonna do that. So if you're interested in that, stay tuned.